Symmetry is beautiful. We see it everywhere, sitting behind the wheel of a car, admiring architecture, films, or when we are looking for a beautiful person for ourselves. Symmetry can be familiar, frightening, and even deadly. And one day, symmetry almost destroyed all matter in the universe. Now you will learn why symmetry and asymmetry affect our lives and the life of everything on Earth. How the universe was divided into right and left. Look, it's a snail. Pay attention to its shell. It is twisted to the right like most snails. Most, but not all. The shell has a 1 million chance of being twisted to the left. This is what happened to Jeremy, for example. You've probably heard of him. In appearance, this is an ordinary snail, but its spiral is twisted to the left. Just think, what difference does it make where the shell is twisted in general? But finding a mate for such snails is not easy. Individuals with different types of shells cannot mate, simply because their genitals are mirrored. It is as impossible as greeting your right hand with your left hand or completely combining it. They seem to be the same, but this is impossible. Jeremy was lucky. A flash mob was launched on Twitter with the hashtag #SnailLove. He attracted attention. Jeremy finally found his love. And they had children. At the same time, their shells turned out to be quite ordinary, twisting to the right. This incident got me thinking, why does this happen? When did the world begin to divide into right and left? And why is this so important? The search for answers has gone quite far. And now I want to tell you what the secret meaning of symmetry lies. Let's start with an interesting story. Jeremy's symmetry case is strange, but it's not the most surprising thing in this episode. Let's understand once and for all what symmetry is and what it can be. If we rotate an object or reflect it in a mirror, and even if we rotate it along all axes, and its appearance does not change, it means it is symmetrical. Okay, 2D and 3D symmetries are easy to imagine. What about the symmetry of a 57-dimensional object? Naturally, we can see it only in projections onto a plane. But this is not yet the most incredible symmetry. The most incredible is the symmetry that exists in 248 dimensions. Wow, seriously? Yes. It was as if we were in the shoes of Dr. Strange. But in fact, our minds are not so cool as to imagine this whole story. But for mathematicians, nothing is impossible. In real life, similar symmetry was shown by electrons in a crystal from cobalt and niobium. We humans are also symmetrical, at least externally, or we try to be like that. Our left parts are similar to our right, but there are organisms with much more interesting symmetry. For single-celled organisms, bottom, top, left, and right have no meaning at all. They just float there in their solution. But at the same time, they have the most perfect symmetry, spherical. Any cut through the center of the body divides it into equal parts. I also have something for a perfectionist. They are called radiolarians. Look how beautiful and scary the creatures are. They always fascinated me in biological encyclopedias. But to be a ball, you need to remain very small. Once you gain mass, gravity will prevent you from being spherical. Such creatures move to another level of symmetry, radial. This is when a body remains the same if you rotate it around its axis at a certain angle. This happens with starfish, hydras, and jellyfish. If the dog can only be turned once to return it to its original position, then the starfish needs to be turned 5 times. A boring, inactive life. But sometimes it has its advantages. Look, this is the jellyfish Aurelia aurita. Its larva can swim even when it loses a limb. She simply redistributes what is left and restores symmetry. She can do this again and again, even when there are only 2 blades left. It turns out that symmetry is simply necessary for their life. But in order to climb the evolutionary ladder, you have to move faster yourself, catch more prey, and stupidly run forward so as not to become a victim. Therefore, the front half of the body begins to differ from the back. The sense organs and mouth move there. All that remains is the symmetry of the left and right halves. It's called bilateral. And this is great for moving forward. Turbellaria were the first to guess this 500 million years ago. We humans are also bilaterally symmetrical. The left and right halves of our body become symmetrical even in the embryonic state. There is a complex mechanism behind it, and this guy managed to uncover it. Alan Turing. You probably know him from the Turing test and breaking the Enigma cipher machine. He theorized that if living tissue had two specific substances that influenced each other's production, they could create unique patterns. This is how mathematics explained how spots and stripes form on animal skins, blood clots, and even tumors grow. Surprisingly, the symmetrical body of the embryo obeys the same laws. There are two groups of proteins. One is unevenly distributed along the length of the body, another in width. It is these proteins that turn this into this, and this is in this. These same proteins determine how many fingers we have. This is how they merge into the familiar outlines of the brush. In just 2 days, you get finished fingers. 48 hours, and you use it all your life. But sometimes the mechanism fails and symmetry appears where it should not exist. Something, this reminds me of something like that. Somehow it's not even very attractive, yes? Many species, from fruit flies to humans, choose the most symmetrical partner. Such individuals have fewer failures in the genetic program, which means the offspring will be healthy. Look how handsome he is. It's as if it was mirrored in Photoshop. But this is just a perfect toad. One study even found that women orgasm more often with men who are more symmetrical, regardless of their experience. But there is symmetry that is inaccessible to a living creature. Diamonds are made this way by nature. Pyrite crystals, too. Nature also makes viruses symmetrical. Yes, viruses are not exactly living organisms. They have genes and evolve, but they do not have cells or their own metabolism. Therefore, it is most correct to call them organisms on the border of life. Thanks to this kind of life, half alive and half not, they can take beautiful and strange forms. For example, spirals or icosahedrons. With such symmetry, viruses solve a purely mathematical problem about saving, how to build their body so that there are more resources left to capture other cells. For example, bacteriophages, similar to aliens, combine spirals and a regular polyhedron. They hide their genetic weapons in the icosahedron, and through the spirals they inject their genes into bacteria, forcing them to create thousands of copies of themselves. Yes, but what about plants? They don't seem to obey the laws of symmetry. Look at it. Complete chaos, but not quite. The plant obeys a completely different law. The law of fractals or fractal symmetry. You've probably seen fractals. These are figures whose shapes are similar to the shapes of their parts. This is what people see when they take all sorts of fun, relaxing substances. But why does nature need fractals? This symmetry allows resources to be delivered to the most distant part of the body, saving energy and space. For example, to deliver water, air to the lungs and blood. Fractals of different nature turned out to be so similar that scientists were able to turn leaf veins into blood vessels by transplanting heart tissue there. Do you understand? It turns out that symmetry at all levels, from plants to animals, from rivers to electrical discharges in the atmosphere, works according to the same laws. Here we understand that symmetry seems to have some greater meaning than just right and left. But why then is not the whole world symmetrical? Right? Why then is there always a right and a left in the world? And in general, how do molecules understand where is right and where is left? Left. This is where the heart is, I'm not mistaken, right? Is it true? Not always. In fact, initially the embryo has two symmetrical hearts, but 22 days after conception they merge into one and shift to the left. This occurs due to the fact that special intracellular cilia in embryos transport the same Turing substances from the right half to the left, but sometimes to the right, if you won the genetic lottery and your organs are mirrored. This happens to 1 in 20,000. The heart is on the right and the liver is on the left. I don't know if it's cool or not, I only know that it's not harmful. If the inversion is absolute and the work of all organs is coordinated, then nothing interferes with each other's work. Everything is fine. Enrique Iglesias and actress Catherine O'Hara from the movie Home Alone received this feature. Yes, it can be dangerous. Singer Donny Osmond almost died due to the mirror arrangement of his organs. When doctors who did not know about this could not make a correct diagnosis for a long time due to the mirror location of the appendix. But what's interesting is, what is right and left at the most fundamental level? What is right and left at the particle level? I'll try to explain everything to you in layman's terms. Literally, If you make a cast of your palm, like on the Walk of Fame, the left one, and try to put your right palm in it, then nothing will work, right? Because they don't match. Such objects are called chiral. In the mirror, a right-handed person turns into a left-handed person, and vice versa, and the objects become incompatible. This is chirality. This is typical for plants and animals. There are shells twisted to the right and left, and even the right and left beaks of the crosses. So various substances, for example amino acids, which make up proteins that are inside us, can also be mirror images. Despite the fact that they are the same in composition, their frame is mirror opposite. Some are left and others are right. They look similar in appearance, right? But the properties are so different. For example, the penicillamine molecule. The left one serves as a cure for heavy metal poisoning, and the right molecule of the poison causes blindness, but at the same time they are twins. Their actions are opposite because they cling to molecules in our body differently. Try, to make it clear, shake your right hand, your left hand, and you will understand what I am talking about. The difference between right and left molecules is so strong that any of us can smell and taste it. Take orange and lemon, smell it. These fruits contain the same odorous substance, limonene. Only in mirror version, the left one is in the lemon, the right one is in the orange. If we synthesize amino acids artificially, we will always get an absolutely equal number of left and right-handed molecules. But for some reason, all the bodies of absolutely all living organisms in nature are built on left-handed amino acids. But why specifically on the left? To answer this question, we need to look at the universe. Asymmetry did not originate on Earth. It is of extraterrestrial origin. Meteorites that come to us from afar also contain amino acids, and there are more left ones among them. But what could make them left-sided? There are some good, interesting theories about this. This could be done by polarized ultraviolet light, which appears where new stars are born, for example, in the Orion Nebula. Such light destroys the right amino acids and leaves the left ones. It is the left amino acids that once came to Earth with the help of meteorites. They could form living proteins, from which all the rest of life on the planet then began. Perhaps somewhere in the universe life is built on right-handed amino acids, and when we get there, we will be treated to local food, but we will not be able to get enough. No matter how much we eat, we will die of hunger there, since we will not be able to use mirror molecules to build our cells. It's like the right and left hand, remember? But there is another theory, deeper. The theory goes into quantum physics. Elementary particles rotate around their axis, left or right, but not in the literal sense, but on the quantum level. But a simple electron is picky, and during radioactive beta decay, it chooses only the left direction. Along the chain, it knocks out the same left-handed electrons, and they destroy all the right amino acids and leave only the left ones. It's hard to believe. But thanks to symmetry and asymmetry, everything can be explained. Everything you know, everything you remember, everything that exists in the universe. Matter, that is, the Earth, other planets, stars, our bodies, laptops, the camera with which I shoot. And the screen on which you are viewing me exists thanks to asymmetry. Yes, I understand, it sounds simply crazy, but just as at the very beginning, the birth of the universe, now in the vacuum of space, a certain amount of matter and antimatter is constantly being formed. According to the laws of physics, matter and antimatter constantly destroy each other, each time emitting a photon, a particle of light. Imagine Tetris, made up of red and black blocks that constantly connect and disappear, leaving a tiny bit of light behind. We can still observe this light in the form of cosmic microwave background radiation. The entire space, the entire universe, is filled with old light from these very flares. Now imagine that in such a fraction of a second, after the big explosion, there are one more red blocks for 1 billion black blocks. And it turns out that this red one will not be able to find a mate to destroy itself. Red blocks are the very substance that makes up everything that we know, see, and feel. These are the very particles that could not find a pair among the antiparticles. Soon these particles, thanks to gravity, began to gather into clouds, into stars, into stellar systems, into planets, and even into us. If the newborn universe would be absolutely symmetrical, That is, matter and antimatter would be formed in equal quantities. And out of a billion particles, that very small elementary particle from that very red block would not have appeared. And nothing, no planets, no stars, and especially not us. And on this map there would be nothing but light from the symmetrical mutual destruction of those same particles. We are the result of the superiority of matter over antimatter, the results of the asymmetry of matter and antimatter, the results of the struggle between right and left. Everything we know and see in nature, spheres, fractals, spirals, animal spots, our bodies, the position of the heart, the circulatory system, the two halves of our brain, and even the ability of two snails to have children, were built thanks to the interweaving of symmetry and asymmetry billions of years ago. And everything still works according to the same law. Thank you for watching the video. If you have questions, write them in the comments. And also check out our channel, we have some more interesting videos.